Welcome to our Kornucopia ML Quick Start training class. This class consists of a set of videos that will help you learn essential skills to leverage the many software features of Kornucopia ML, a uniquely powerful toolbox for use with MATLAB. The video series you are watching is an edited version of a live Zoom-based class that was taught by myself, Dr. Ted Deal, the developer of Kornucopia. The class is being presented using a combination of PowerPoint slides and live Kornucopia ML calculations in MATLAB. You are encouraged to frequently pause the videos as needed so that you too can explore the calculations that are being demonstrated. Please note that there is a download link on our website associated with this class for obtaining the PDF course notes file and several workshops, as well as some files of the script snippets that are demonstrated. If you are new to Kornucopia and need to access the Kornucopia ML software itself, please use our Contact Us page to request the software download link and a free, fully featured Kornucopia ML demo software license. Two final notes. Because these edited videos are based on a class that was presented live, there may be some comments occasionally in the videos that reference emails or other interactions with the live attendees directly. Also, you may find some portions of the video appear slightly blurry for brief sections of time. This was an unfortunate artifact of the Zoom video recording. This is the course content that we're going to go over. I did give you an email the other day with some videos to watch. If people watch those, great. If not, that's okay. But they will have described a lot of different features in Kornucopia. One of the things about Kornucopia is it has a tremendous amount of capability in a variety of areas. And so, some people that are familiar with MATLAB will be like Google searching to find somebody's function that does this, that, or the other thing. With Kornucopia, you don't Google search to find Kornucopia features. I will show you how to use the very detailed help. And there's, Kornucopia was written by myself, who's a practicing engineer, who's got lots of years of experience doing nonlinear FEA, as well as experiments. So I've tried to put all those functionalities into this one toolbox. So there'll be a lot of features that you might not think of, as some function might exist to do what you want. Looking at the help system will be very helpful to you. So I'm going to give you a brief glance of its features, but there's many more features than what I'm going to cover in that glance. Then we'll talk a little bit about how do you get help in finding the functions and examples that are in the code. And then we'll dive into the heart of the data type called k_units, which is how Kornucopia holds data and units and other information. That'll be a fairly deep dive into that because we're going to be doing scripts, and scripts are syntax oriented. Then I will talk about a few other syntax features in Kornucopia. Then we'll talk a bit about importing and exporting data files with Kornucopia functions. Then, obviously you want to be able to plot data. So we'll talk about plotting curves. And then a lot of people will end up with workflows where they'll have lots of plots they need to manage. And so Kornucopia has a technology based on tabbed plots to do that. And then we will finish off with some actual workflows or workshops that go through complete workflows. So that's going to be the nature of the course. We have lawyers as before. One of the things you'll notice different from the other ones is I don't have a restraint here regarding copying or sharing this information. So the PDFs that you have, you're welcome to share those with other colleagues. And I will be recording this course and publishing that up on our website. And for those who are unfamiliar with Bodhi Tech, we have our Kornucopia ML software, which is what you're getting trained on right now. We have other training courses on generally processing noisy, messy data, and some others on generic nonlinear mechanic techniques like energy methods. And then we do some consulting as well. And we have alliances with MathWorks because Kornucopia is built on top of MATLAB, DS Simulia, the makers of Abacus, and PCB and Endevco. All right, so let's do a little bit of an overview of Kornucopia. So the focus of the software is to allow you to work in a very natural way with all the information you would normally have, not just an array of numbers, but units, image information, and other meta information that you might have related to problems you're working on. The data analysis and the tools are oriented at both physical testing needs and those doing transient simulation like transient FEA and other challenging kind of work like that. And the tools are all derived to work with real world data that's typically going to be messy, noisy, nonlinear, rather complicated data, not just simple straight lines. And when you work with a lot of that kind of data, you end up making a lot of plots. And so Kornucopia has a lot of features to enable the automation and generation of these plots and to manage a ton of them so that you can work efficiently and clearly communicate your results. So I'm just going to describe, just to get everybody to some common understanding of what kind of the feature set is in the tools, just a couple of generic workflows that people would have. So here's a typical data scenario where somebody is getting a data file. It's ASCII format coming from some test system. This happens to be an MTS test data file. And what you see in this data file are a number of data sets for different samples that were measured. They're all stacked in the file. And in a given data set, there are columns with appropriate column names and units and other information related to the specimen. All that grouped and then stacked one on top of another. With Kornucopia, it's quite easy to readily read that in with the kread text function, and then using the kplot function, be able to easily plot the data and have the data plotted, including all the labeling shown here, in a nice automatic, easy way. Once you have that kind of thing, in this particular example, this data needs to be cleaned up. It's got some towing at the beginning, and the data all has failures at the end. And so Kornucopia has a host of functions to enable you to easily trim, tweak, shift, clean up that data, compute an average curve from all the curves, and even fit that curve if you want to some fitting function. And it will all work with units as presented here in a nice, proper workflow. On the other end of the spectrum, so this is kind of like instron work or uniaxial tension measurement work on the left. On the right would be the typical highly noisy transient simulation of something impact or similar thing like that, where you might have some physical test data and raw FEA data. They don't look to correlate at all. We could do Fourier spectrums, then define a filter to apply to the data and turn what appeared to be a complete mess into a very successful simulation and correlation to a test. These are the general workflows that people use Kornucopia in, plus a few others, and I will try to highlight those and the syntax and the methodologies and functions to do that. When you do this kind of work, it's very common that you will generate a large amount of plots. In the traditional MATLAB approach to plotting, you would generate a figure window and put one plot in a figure window or maybe a few with a subplot command. And you can manage 4, 5, 6, 10 plots that way. But when you start generating analysis workflows that generate 70 or 80 plots, that's not at all manageable with that kind of approach. So Kornucopia has developed this approach with tab figures and functions to make this very easy to do and efficient so that you can generate and store data like depicted here in this plot. And you end up with a very orderly workflow. The presentation of your results is very orderly. You can quickly compare various results within the plot by popping out various portions of the plot into separate windows to put them side by side to temporarily compare them. You can save this figure window. It's kind of like a database. And then you can open it back up later, give it to a colleague. And when they open it up, if they have Kornucopia, they can actually retrieve data back out of the figure very easily. If they don't have Kornucopia and just have MATLAB, they can still go look through the figure and whatnot. If they're really highly MATLAB knowledgeable, they could ultimately retrieve the raw data behind the curves. Would that be a bit onerous? But if you have Kornucopia, it's very easy with one click to right click on a particular plot and request different curves that come back out, and it will come out with all the original data, units, column names, and such. So it's very meta-rich information. You can also attach virtually anything you want to the figure window when you save it. So you could attach your script, you could attach spreadsheets, PowerPoints, videos, all kinds of stuff. So this ends up to be like a nice virtual art database and archive. And then one final thing, it's very easy for you to generate a PDF of all of these plots by simply using the Figure Windows Kornucopia menu. This one figure that I'm demonstrating here might hold as many as 100 plots in it, all in this one orderly, nice tabbed figure window. So one of the things I will be showing later in the course and in the workshops is how to generate these kind of approaches so that you can efficiently really process a lot of data. Here's just a little live video that we're going to show of an example of this kind of thing. So you start right off with a nice description of the problem as a picture. We have some of the raw data that we've read in this nice scrollable table, so somebody could look at that later if they were interested. And then we start to walk through the analysis process, where on each of these tabs, we have various plots that are all nicely labeled. If the plot's a little small for you, you can easily pop it out into a bigger window, and then you can make the window as big as you want. A lot of people nowadays have either really large monitors or 2 monitors, so it's not uncommon to put the various plots on different monitors. And then as we continue through this demonstration, we're showing as the raw data has been mapped, filtered, integrated, and whatnot. We have various things. We even have comments written down on the things, and then complicated plots here. And now here what we're going to do is just demonstrate extracting data back out of the curves. So these are all Kornucopia features that allow you to easily highlight various curves, or in a minute we're going to pick a couple, and then instead of trimming it, we're just going to go here, and there's some different controls you can select to decide how you want the data to retrieve back out. Here we're retrieving it back out, back to the MATLAB session. So this might have been an example if somebody had given me this figure window. And now in the MATLAB session, I can then go look at the variable that got returned. We picked a couple of curves, so it's returned as cell arrays. If I look at each one, they're all well-documented Kornucopia data types, with not only just the raw data as you see, but additional things like user data, which as we dig down a little bit here into these properties, which I will be describing soon in this course, we're going to ultimately show you that we have recorded additional details about what filtering had occurred to the data that was in that plot. All that kind of stuff is the kind of things that you're going to learn about in the course over the next couple of days. Okay, so to be able to do all that, the K-units data type is at the heart of Kornucopia, and then it's surrounded by a ton of tools. So there are over 125 different high-level functions in Kornucopia that are in these various categories. In the 2-day course, I cannot go through every one of the functions. So what I will encourage you to do is I will highlight a few of them here and there, but definitely take some time and look through the stuff that's in the help system, which I'll be describing shortly, to really get the full understanding of the capabilities in the software. And again, the software is pointed at somebody who's working with physical test data or working with a lot of simulation results. So to make Kornucopia work in a fairly natural way within the MATLAB environment, Kornucopia has overloaded more than 80 MATLAB functions. These are generally kind of math functions, statistics functions, and similar functions like that. And what overloaded means is that those functions will work with the K-units data type. Now, on top of that kind of basic functionality, Kornucopia has a very large array of custom functions that it has created. There's over 125 of these native Kornucopia ML functions, and they're categorized in the various groups you see listed here on the screen. So you were given links to these videos. The videos go through a few more overviews and example demonstrations of using the software. That gives you a better understanding of the capabilities. We will highlight some of them here, but if you are watching the videos after the original given of the live course, I would encourage you to stop the video and watch these videos if you haven't already. For those of you in the live course, of course, we're not going to do that, but we will start looking at a couple different features within the software. So, the important thing with software is to figure out how do I get some help and guidance, and how do I find things like functions and examples. So we have to start with the MATLAB environment. So what I've depicted here in the upper left is a common setup of the MATLAB environment. If you open up MATLAB, you would have some command windows or some sub areas within the environment. So the command window here is where you would just type commands if you want to type a command and have something echo back immediately. You would have a listing of what folders and files are in the particular directory you're in. And once you start to put variables into the workspace, they will be listed in this workspace area. Now, what somebody would typically do would be they would open up some type of script, either a traditional script or the new style called the live script. Kornucopia is generally used with traditional scripts, although you can use the live editor if you want. But this training is going to focus on the traditional scripting approach. So when you do that, now we have a MATLAB environment looks like this. We have our script editor, the variable workspace, the command window has been shrunk down a bit. And what we will suggest for Kornucopia use, you don't have to do this, it's just a suggestion, is that you grab these windows by their top bars and move them around a little bit to get a configuration like this, where you have your files and folders and workspace variables over here on the left, the script editor in the middle, and the command window to the right. As you'll see when I demonstrate some uses, having it set up like this is a little bit more appropriate for the style of work that you'll typically do with Kornucopia. So this is not a requirement, this is just a suggestion. If you do that suggestion, then you will want to save that layout. So back here on the Home tab, under Layout, you would pick Save Layout and give it some name like, I don't know, Kornucopia layout or whatever. And then in the future, when you're using MATLAB, if one of these other layouts occur, you can just come to the layout and pick your layout back and it'll easily come back as it is. If anybody is trying to rearrange this from this format to this and they're having trouble, at the break, I will try to help you. Or at the end of class in the overtime question section, I'll be glad to try to help you. All right, so how do you get help on Kornucopia? So when you install Kornucopia onto your computer, if you have a Windows computer and you said yes during installation for an icon to appear on your desktop, you could just click on the icon and the Kornucopia HTML help system will open up. Alternatively, in the MATLAB command window, so you're in the MATLAB environment. So we'll just go back here a second. So here's the MATLAB environment. Here's the command window over here. So if I was in the command window and I literally just typed K_ to help, that will open up the Kornucopia help system. And then the third style to get help is you're working something in the editor. You have a Kornucopia function. You put your mouse on the function and you hit the F1 key. This is a general Windows scenario kind of thing. And it will open up what's called brief help. So this is the brief help that's opened up. And it'll describe briefly some help about that function. And then in all the brief help things for Kornucopia, there will be a link down here. If you click that, it will open up the Kornucopia help system to that page. This little thing over here for viewing the code will be pretty much useless to you because all of Kornucopia's functions are P-coded, so you will not be able to see the raw guts of the code, but the help system is very detailed and will give you all the information you need to know about how to successfully use the function. A quick note, if you're in the MATLAB environment and you go into the MATLAB help area and you try to search there, all you're going to get is MATLAB native function help. You won't get anything about Kornucopia. You have to use one of these methods to get the Kornucopia help system to open up. Okay, so the next thing that we want to look at is how do we get to functions in Kornucopia. So I'm going to show a couple slides here. I'm going to show something on a slide here for a moment, and then I'm going to switch over to MATLAB and show live how this works. But if you're in the command window, all of Kornucopia's functions begin with K_. So one of the powers of MATLAB is it has like a million functions. So one of the challenges of MATLAB is it has a million functions. So finding what you need can be challenging. Kornucopia's functions are all nicely labeled and named in a way that makes them easy to search for, just based on doing K_ and hit the tab key. When you hit the tab key in MATLAB, that will try to self-complete things. So here it will give you a list of the Kornucopia functions that you could then start to pick from. If you are in the script editor and you're in MATLAB version 2021A or older, and that's actually what I'm demonstrating in the training today, you can equally hit the K underscore and hit the tab key, and you will get this nice alphabetical list that you can pick from for the functions. If you happen to be using the more newer versions of MATLAB 2021B or R2022A, these lists in the editor will not be alphabetical. They're now based on some AI logic. Since the list is 125 functions, you will find that to be very difficult to find your functions because they'll just appear in a random order to you. In the command window, they will still appear orderly, so you would want to go into the command window if you're using these newer versions of MATLAB to get the orderly list. And of course, you can always open up the Kornucopia help system. They're listed there alphabetically and in categories, as I'll be showing momentarily. Because Kornucopia's functions are all labeled and named in a logical way, like all the abacus-oriented functions are K underscore ABQ something. The functions related to plotting are K underscore plot something. The functions related to pulse creation and manipulation are K underscore pulse something. So having them show up alphabetically makes it very easy to find them. So that's just, if you're using the most newest version of MATLAB, they change the behavior, and these lists only will show up this way in the command window, but not in the editor. All right, so let's just quickly pop over to MATLAB and let's demonstrate this. So I'm in the MATLAB environment, and first I'll just demonstrate in the command window. I'm typing K underscore, and then I'm hitting the tab key. And when I do that, MATLAB tries to self-complete the thing, but since there's many things that begin with K underscore, it gives me a list. But the list is all scrollable, and it's all in a nice alphabetical order, easy to find things. Kornucopia's namings are tried to be named in such a way that you would easily be able to type things. Like if I'm interested in reading functions, if I just start typing READ, I get to the read things. And here's read text and a couple other reading related functions. So that's how Kornucopia's naming works. And the same thing will work in the text editor. I hit the tab key and I get the same kind of thing. If I open up the first one, which is going to help. So if I do it in the editor, I've just put a command in there, I haven't executed it. If I do the same thing over here in the command window, and now I execute that, Kornucopia's help system will open up. It's an HTML-based help system. And the very first time you start MATLAB and open up a MATLAB session and issue a Kornucopia command, Kornucopia will take a moment to load a bunch of stuff into memory related to Kornucopia. It's kind of like loading a toolbox. And so that's the momentary delay we saw here. And it's got some basic stuff about Kornucopia. And now here in a second, the HTML help system opened up. And of course, it opened in the other window. So I've just drug it over here. It's got a tree, which has lots of information. We can poke at various things, and there's very, very detailed information. So if I wanted to learn about the K-units data type, it's a complete, full help system with a ton of information. If I want to look at functions, I could get an alphabetical listing with a brief description. If I picked on some function like I was interested in about decimation, I could start to read about it, what the syntax is, what the arguments are that you would put in, advanced arguments, what comes out, examples of its use. And at the very end, other examples in the Kornucopia library of examples that describe where this function is used in a particular example. So unlike the modern trend of help systems, which is the help system is very thin and they just tell you to go on the web and Google search, Kornucopia is still a strong help system with lots and lots of information in it. All right, so I just went through an example help page for the decimation function here. I'm just highlighting the help for the K underscore filter function. The key points are on a Kornucopia help page for every function, all 125 of them in the software. You'll get detailed information about the calling syntax, which usually will have a couple of different syntax options. Explanation of the various input arguments that go into the function. Explanation of what kind of output will come out of the function. details of the advanced optional arguments. ADV is short for advanced, so there's optional advanced arguments that allow you to control the behavior of the various functions. And then there'll be simple depictions of the function use, where you can copy that code into a MATLAB window to execute and play with it yourself. And then at the end of the help page, as I showed a moment ago, there will be links to full examples that utilize that specific function. So unlike what we kind of have been taught with the iPhones and the latest stuff, I strongly suggest you're using a new function, unless you think it's a simple thing. I strongly ask you to consider reading the actual help page about the function. There's a lot of information there. You'll learn a lot, and that'll allow you to really take full advantage of the function's capabilities. The other thing you would want to potentially do is open up examples. So in Kornucopia, there's a variety of examples. So the first 9 examples in the help system are all tutorials. They're detailed examples that are designed to teach you how to do certain things, starting from simple calculations all the way to importing and reading data files, writing them out, and a couple special issues with working with frequencies and temperature. And then after that in the list, there's about 40 examples that are general purpose examples that demonstrate all kinds of things. Some are typical workflows like this ball lens impact example. Some are detailed discussions about averaging curves and all the various kind of flavors of averaging techniques you could use, all listed in the help system. You can also go into Kornucopia's help system itself and look at these examples as published HTMLs. They're kind of like PDFs, but it's HTMLs, where the example was already run and you can quickly look at it, but that's like a static kind of thing. Opening up live, you can interact with it. So you can do something like this. So I'm going to type K_EXA and hit tab as it starts to self-complete. There's 3 functions that have the word example in them. And so this one here, examples open, is the function I'm going to use. That was just highlighted on this PowerPoint a moment ago. And now I have an interactive selector that I can pick from various examples in the Kornucopia library. So let's say I were to pick on this one about the ball lens impact. I can open that up. It will take the actual example file and it will bring it into your local workspace called My Kornucopia. This is a folder that gets installed when Kornucopia is installed on your computer. And so it's going to take a copy of the original example and it'll bring it in there. And if you already have one in there, as I do, it'll give you a choice of, do I want to back up the copy that I already have in my Kornucopia folder, or do I just want to blow it away and replace it with a new one? So I'll do that. I'll just blow it away. And then you'll always be asked, do you want the heavy or light version of comments in the examples? In reality, there's not much of a difference here. You're going to find all the examples are fairly heavily commented. So it really doesn't make a big difference what you pick. And then the example will open up like this. The examples are written in sections. Traditional MATLAB users that I run into, their scripts have very little comments. They have clear all at the top and whatever code they have, and they just hit the run button. In Kornucopia, you will be suggested not to do that, but instead use run in advance or run section and advance separately. These buttons will allow you to run each section by themselves. The first 2 in this example are just commentary, but then we start to have a part of the example with some code, some more code, and you can run each section. And then as you run each section, you can consume the result. The result will be popped up on the screen or displayed in the command window, whatnot, and you can walk your way through the example in a nice orderly way to consume that. So if I just demonstrate that really quick with a couple of steps here. So I'm going to get this pop-up. This pop-up is interactively asking me, do I want to kind of clear out the memory and close any windows that are open and set this to home, which makes us move up to the top. I'll say yes. We'll talk about this a little bit later. And now that I've done that, I'm going to come to the next section here after it's popped up an initial figure window where I'm going to be storing and showing you some results. And as I go to this next section, I'm loading the data. And the first thing I'm loading is a nice picture description. You saw this a minute ago in a video. And I've also loaded the data, and I'm showing a plot of it here and the second plot here. The computer is a little slow here, I think, because of the zoom that I'm doing. And then I could keep walking through section by section, plotting the data and doing calculations and whatnot. Here I'm computing a discrete Fourier series and whatnot as I go through this example. So I'm not going to spend the time with this example right now. I'm just trying to give you an idea of what's possible. All right, so that's how you would go poke at examples live, and then you could easily look at them as pre-published results in the help system of Kornucopia itself. So that was a quick glance of like a little bit of the concepts of some of the workflows and how you go get help. And so now what we're going to dive into is the K-units data type. This is the heart of how Kornucopia holds data, and it's the basis on which all these functions will interact with data that you work with. So this is a really important section to pay attention to and to understand. People who are new to the software, they're accustomed to only working with arrays of numbers from like Excel and things like that, or Python, or even traditional MATLAB. And so they get a little tripped up on this data type initially, but the purpose of this training is to remove that step so that you really understand it. Once you do, you see the power of it, and you'll see how it can really help your workflows tremendously. Now, in the Kornucopia help system, on the tree over on the left, there's a thing all about the K-units data type. If you click on that, there are many subsections, and all of them have a lot of detailed discussion on the topic of this data type. It's very, very powerful data type. So with a lot of power comes a little bit of responsibility. So, I encourage you to look at this. In the training here, we're going to try to shortcut this a little bit by showing you the key features. But, if you find Kornucopia compelling and you really want to become a power user, spend a little time when you have some breaks in your workday or whatever and glance at some of these pages. You'll really understand the full power of the syntax and its technology, which will really allow you to exploit it to its maximum benefit. Now, somebody doing Kornucopia calculations in MATLAB will work with a variety of data types. K-units will be one of the data types, but they'll also likely be using a variety of MATLAB data structures. So the most traditional one that everybody who uses MATLAB is most definitely used and is probably familiar with is a double. That's a type where the data is stored as double precision, and it's just an array of numbers. It could be a single value or multiple rows and columns, but it's holding just data at double precision. There are two types of data types that hold character arrays. So the original one was called a char, and it's used in MATLAB with single quotes. So there's an example here of some stuff. That would be a char array. It could have multiple rows, but char arrays with multiple rows have to have the exact same number of columns of characters. So that's a little bit constraining. We'll learn about something in a minute to help mitigate that. But more recently, they came up with a data type called a string. Those are defined with double quotes. Here is an example with double quotes around it is a MATLAB string. Kornucopia generally does not use these. They use the char instead. That comes for some historical reasons of when Kornucopia was originally developed. And in particular, in addition to that, when Kornucopia was originally developed on the MATLAB platform, there was no string data type. And MATLAB, as well as Kornucopia, would use the word string to mean a char. So now we have a little bit of confusion here that they came up with a string data type. So in Kornucopia's terminology and descriptions, unless the word MATLAB string is specifically said that way, and it's referencing something in double quotes, if you see the word string in Kornucopia help system and whatnot, what they're really referencing is the single quoted char approach. There are a variety of other data types that might be used, like logicals, the struct, which allows you to hold a structure of data, cell arrays, which are general containers that can hold anything. A cell string is a cell array who holds just elements of chars. So that's how you would hold multiple char arrays with different number of columns and whatnot. You would use something called a cell string. And then MATLAB has a data type called a table for tabular-like data, where you can put in column names and some other information. And in fact, the Kornucopia K-units data type was inspired by that, but is quite a bit more elaborate. And in the event you are familiar with the table data type and you wanted to put a K-units array in it, you can do that. You just wrap it with a cell array. These are some specifics. For some people, that might not be important. For others, that little tip might be helpful. Now for Kornucopia itself, Kornucopia has the K-units data type. That's a tabular data type that holds numeric data, units, and other meta info. And in just the next slide, I'm going to start delving into that in quite a bit of detail. For when you do curve fitting or interpolation, Kornucopia will generate something called a K-func data type. That'll allow you to manipulate data from curve fits and interpolations. And then when you start to work with the with the tabbed figures, Kornucopia has another data type, the K-fig tabs handle, and that gets created when you are creating tabs with Kornucopia's functionality. So right now, we're not going to concentrate on anything except for predominantly this K-units data type. So with the K-units data type, you can hold a large amount of information in a single variable like that looks like or feels like a container. So normally in MATLAB, as I showed a moment ago, people will be holding data in a double, and it'll just be an array of numbers. And the problem with that, if I just go back and I ask anybody, what's in the second column of this data? Nobody has any idea. What units are the data in? Nobody has any idea. Things that are, where did the data come from? No information about that. So with the K-units data type, you can hold your data in columns. And in each of the columns, you can have a unit. So you could have units like acceleration in G's, pressure in kilopascals or whatnot, or as an example here, we have time in milliseconds, acceleration in thousands of G's, a velocity in millimeters per second, and a strain in percent. You can have column names. You can have column comments. You can have a general description about the variable. You can also have row names and row comments. And you can have a user data, which is like a general bucket you can put anything in. And there's even this parameter called dimension names. This is rarely used. The blocks in gray are optional, so you don't have to define those if you don't want to for a variable, but you can if you want. The sections in green are required, so we would always have data and some units related to them. It could be unitless, or they could have units. So we can store data like this, and then in MATLAB, we can generate scripts with calculations like shown here, where I'm computing some effective mass, multiplying the number 5 times the unit of pounds mass. Then I'm computing a radius in terms of centimeters. So you see I'm mixing various flavors of units and doing a calculation. And here I'm referencing the third or the A3 column out of this data set to compute a stress, and then finding the max of it, and then reporting that in the command window. Kornucopia will handle all this, including all the mixed units. And the purpose of this training is to explain how this all works and how you do this. Plus using advanced features as well, but we have to start here. So this data type K-units is really known as a class in MATLAB. And so you'll be learning how you can generate data that will present itself like this, which is very clear what I have. And it comes from this kind of concept of the K-units class. So in this K-units class, this gets provided by Kornucopia to MATLAB. It has both properties, which are listed here. And the properties are all the things you see, like the column names, the units, the data, those are all properties. And then methods are things that can do special actions, like the convert method will convert various columns or the entire array from one set of units to another if you want. Data size will give you the size of the data in the tabular-like array. And then toStruct and toTable are two methods that will allow you to very easily take a data that's in this KUnits data format and map it over to a MATLAB structure or a MATLAB table so that you could then give it to any MATLAB user and they would be able to see fully the information you have. So this data type was definitely inspired by the MATLAB table, but it goes much farther than what MATLAB's table does. There's a seamless units engine that's connected to this all that Kornucopia manages. It provides also several additional syntax behaviors that the KUnits offers that's quite efficient, allows you to work fast and easy with this format. And there's over 80 MATLAB functions that were overloaded to work with the KUnits data type. So you don't have to be constantly extracting the numeric data out to do some math and put it back in. Kornucopia will do all of that in a natural way within the MATLAB syntax. So there are 4 ways that you can hold a KUnits data type. So the first is using what's called the KUnits class constructor function. So a simple example here is I'm defining some variable v, and I'm saying the function KUnits, I'm giving 2 basic things, an array of data, which could be a single number or a 2-dimensional numeric array, and then some units that are the units for the data, either one unit that's for the entire array, or a cell array, or a number of units, 1 per column. And then there are additional advanced options, which we'll learn about shortly. That's how we would add things like column names and other meta information to our data set. The second way we generate a KUnits data type is by performing math. So any kind of math that we do, add, subtract, multiply, divide, sines, cosines, any of that kind of stuff. When you do that, if any of the variables in the calculation are KUnits data type, MATLAB will turn the whole calculation over to Kornucopia. The calculation will be done, and what gets returned is a KUnits data type. So in this little calculation here, W times H, if either of these variables are KUnits data type, area will become a KUnits data type. When we import data from any kind of file with a Kornucopia function, it'll import it as a KUnits data type. And then with very few exceptions, almost any calculation using Kornucopia functions will return a KUnits data type, even if none of the arguments fed into the function are KUnits. And again, the help system has a lot of additional details about this. I'm going to go over highlights of it in the class. Okay, so let's go and make ourselves a few KUnits data types. So what I'm going to do is I'm going to now in MATLAB, I'm going to type these live and demonstrate some things. So let me just quickly go into MATLAB Live here. So the first variable I'm going to make is some variable. There's nothing magical about what the variables on the left are, so I'm just calling it LX. And I'm typing K_units, and I've typed a couple letters, K_UN, hit the tab key. And then MATLAB gives me all the functions that have K_UN in them in an alphabetical order. And so what I'm picking here is the K_units function. Then I'm opening up with the left bracket. If I hang out and wait, it gives me a quick little hint of I'm supposed to give it data, and then units as a string or a cell string. So I'm going to enter some data. And in this case, I'm just entering the number 25. And then I'm entering the units. And initially, I'm going to put this in a cell array. And in a moment, I will explain why. And then I'll explain why we can also do it without a cell array. But at the moment, I'm going to put it in with a cell array. So when I do that, Kornucopia enters LX as 25 millimeters. Now, I have a lot of variables over here from the example I opened a minute ago, so I'm just going to quickly go and clean those out. And I'm going to use the cleanup function. So I'm going to enter that. It gives me this little pop-up. And the benefit of this pop-up is when I pick yes, it's going to clear all the variables. So it's going to clean this out. It's going to close any windows that were open, and home is going to scroll this up to the top. It's a little different than what people would traditionally do in MATLAB, where they would do clear all, and they would do CLC, which would totally empty the command window. I don't want to empty it. I just want to make it clear so I could zoom back up if I want to see stuff, but I've just kind of made it so it looks clear to me, and now the variable space is empty. So I'm just going to hit up arrow a couple things to get LX back. So I've just defined this variable LX. It's 25 millimeters. Next, I'm going to define an array. I'm going to do it in 2 steps. First, I'm going to define some numeric data, some values, and the values I'm specifying here. This is the first row, and in MATLAB, in an array, if you put a semicolon like that, that means go to the next row. When we go to the editor, I'll show you another way to do this kind of thing. So the brackets mean to concatenate. So that gets concatenated into a little 3-column and 2-row array. Now I'm going to define this variable b, and I'm going to say it's k_units. And now I'm just going to point at the variable vals. That's my data. And now the units, I'm going to give units for each of these columns. I could give a single unit, which would mean it would apply to all the data, but here I'm going to demonstrate giving units to individual columns. So the first column I'm going to claim is in units of seconds. The next column I'm going to claim is in newtons per meter squared. And the last column I'm going to claim is in pounds force. And so now I've defined B as this data, and I have units. Now I'm going to define this slightly different, this third way. And in the third way, when I do k_units, I'm still feeding in my values, but this kind of thing is annoying to put all these quotes in for every one of these. So instead, I'm going to do something called a string list. This is a Kornucopia concept. And I'm literally just going to put in the units, comma delimited, as a string, not as a cell array of strings, but just as a string. And you see that Kornucopia will gladly take that as well. The reason this works is because for column names and row names and a couple other entities in Kornucopia, a comma is not allowed in the thing. So in the unit list here, commas are not allowed to be part of the unit. So because of that, they can be used as a delimiter. And so then Kornucopia will know if you give a single string like that to delimitate it, to break it up into these 3 different sections. And so now we have the same thing as before. I would claim this is a little bit easier way to type this. So if we go back to the original one, LX, I would have more likely have typed it like this, 25 millimeters. That would have been the same. The reason I'm showing you these cell arrays is because if I ask what is in B, and I ask for, or if I ask for just B, it gives me back this thing like this. If I do that, I can start to look at stuff. So for example, if I say, show me the units of B, it shows it to you as a cell array because it's ultimately stored in a cell array. Even if I feed it as a cell string, it gets stored as a cell array. So I can always use the cell array, or I can use this string list approach. All right, so now I want to take C. So I'm just doing home to push that stuff out of the way. So here's C. It would be nice to have some name to the columns. So I'm going to add some names to the columns, and I'm going to do that by controlling its properties. Right now, its properties for column names are empty. There's no column names, just units. So I can go here and I can say I want to specify column names. I'm using the tab completion to help me complete this. So I'm going to say that the column names are, now I could either do the thing with cell array and quote this, comma, quote that, which is kind of annoying, or I'm going to use the string list concept. So I'm going to say the 3 columns are time, pressure, and left force. And Kornucopia readily takes that in. Column names and things like that, when we go to reference them, will be dependent on their case. And spaces, anywhere in between the stuff is fair game, and Kornucopia will allow you to use that and is perfectly fine to do. I can also add a description to my variable. So I type props and I get a dot and I hit the tab key. So I'm coming down here to description, and I'm going to define a description here first. And now I have a description. And in fact, if I now show what is in C, and it's props, you see the column names has indeed been stored as a cell array, even though I put it in as a string list. And the description even went in as a cell array, as a single cell array. That's because you can have multi-row descriptions if you want, up to like 4 or 5 rows. So this allows you to have a much richer description of the variable when you're using it, passing around, and looking at stuff. What I want to do now is I'm kind of doing some things here live. The PDF charts have copies of kind of what I've done here, but I'm going to stay here in the live MATLAB environment. And what we're going to do is we're going to now start to do some stuff in the editor where we make it a little bit more elaborate and start to do things in the editor. In general, you will work in the editor. You won't be doing a ton of calculations just in this live command window, but you'll generally be making scripts in the editor. So I'm just going to type over here, and just to demonstrate creating with the K units a couple of different things. So what I'm going to demonstrate here is I'm putting in a multi-row cell string for some description. So I'm going to say this is my second K units variable. And so I'm just putting in some goofy little multi-row description that I'm going to reference. And now I'm going to define the variable with the K units array. Oops. And I'm going to put in the values as before. I'm going to put in the units like I did before. And now I'm going to add a couple additional advanced parameters. So instead of creating the column names afterwards with dot props, I'm going to put them in directly into the function call. And I'm going to put in the description as well. So what I'm doing here is, this is from the variable vals that's still in memory. This was before, and now in MATLAB, this is a continuation. So this means go to the next line. And then I have my column names is the keyword, also known as the param name. And then this is the value for a pair. So this is keyword and the value, keyword and the value. And here, this is a variable pointing to this. So now I'm going to come up here and I'm just going to say run section. Try one more time. Oh, it ran it. I have semicolons here at the end, so it didn't echo any command output. So sorry about that. All right, so now I have a variable D. That is the variable that we desire to create. The key point that I want to bring up is that when we do this kind of thing, and you're putting this in like this, the syntax is the data and the units, which is here. And then it's a keyword and a value for whatever number of keywords you want to use in the function call. That concludes part 1 from our Kornucopia ML Quick Start training. Please continue with the next video, part 2, via the link provided on our website.